This is my screencast for Project 3 file systems. In this project, we're going to implement a library that reads a WAD file, builds a file system structure, and supports reading and writing files and directories. Then we're going to have a daemon programs that takes Linux file system request and calls my library function. Let's look at the header file. I store the WAD header in the structure header, and I use a vector to store the descriptor list. And then I use a tree to represent the file system. Each node corresponds to a logical file system element. I also keep a hash map from path to node, so path lookup is faster. The source file. First, we have some helper functions. The build path function converts the relative path to the absolute path. Then we have the three helper functions. It helps me identify the types of descriptor. Normalized path function remove trailing slash. In the constructor, I open the WAD file and read the header and all descriptors. Then I use the identifying helper functions above to build the tree from the flat descriptor list. After this, I have both a tree structure and a path to node map. Then we have this destructor. It recursively deletes nodes using a stack, and this load WAD function returns to a pointer. Now the read-only functions. GetMagic just returns the magic string. Its content checks whether a path exists and is a content file. Its directory checks whether a path is a directory. GetSize returns the file length for content files and the negative one for invalid paths or directories. GetDirectory function pushes the name of direct children into the vector directory, and the getContent function reads bytes from the file slump data using POSIX calls. For the writing part, I also have two helper functions. The readLamp region reads the bytes between the header and the descriptor list, and this rewrite WAD file function rebuilds the whole WAD file using the current header, the lamp region in the parameter, and the descriptor list, the class type. Then we have this create directory function. It checks the path, finds the parent, inserts start and end descriptors, rewrites the WAD file, and reloads the structure into our current class. The create file function is very similar, but it only inserts one empty file descriptor. Finally, the write to file function. It updates the file metadata, rewrites the WAD file, and reloads the object. All the rewrites and reloads operations are finished by the helper functions above. Then the daemon program. The daemon uses one global WAD pointer, and then we have 6 fields callback functions. The get attributes callback is in charge of reading the metadata of the given path. The read directory function gets the children of a directory and passes them to fields. Read function reads file data by calling get contents. The make directory function creates a new directory by calling create directory function. The make node function creates a new file by calling create file function. The write function writes file data by calling write to file function. So the daemon is mostly just a wrapper around the library. In the main function, I load the WAD file, register the fields callbacks, and call fields main function. I also convert the WAD path to an absolute path before loading it. For the library functionality, I run the given library test suite, and you can see we pass all the test cases. And then for the daemon functionality, I use this script to mount the sample1.wad file to this mount directory. And then we went into this mount directory. As we can see, there are some directories and mp.txt file. We use cat to show the content of the mp text file, and we can use make directory AA to make this AA directory. we went into AA and we use nano to create a new file named 01text. And we can see the file is created successfully, and we can see the content of this text file is hello. Finally, we unmount the file system and mount it again. We went into the directory again. We can see all the directory and the file we create is still there.